Since the first reports of explorers returning from afar in the maritime tropics, shallow water reefs have captured the attention of both society and science. Although early reports documented specific reefs or regions, the first attempt at articulating the origin of reefal geomorphic forms was offered by Darwin. He described atolls as circular groups of coral islets, and theorized that coral reefs were tied explicitly to subsiding volcanic substrates. Darwin's approach honors the adage that the present is the key to the past, and represented the application of ergodic principles to geologic and geomorphic questions. In his study of Pacific atolls, Darwin emphasized the widespread geomorphic motif of an interior lagoon surrounded by a rigid reef margin. Expanding on this theme, researchers later suggested that the geometry of modern lagoons is a transient state in an ongoing lagoon-filling process. To further explore this topic, researchers at the University of Kansas conducted a study using a Mike 21 coupled model flexible mesh to explore how hydrodynamics influence the evolution of the geomorphology of atolls. The researchers used a set of physics-based process simulations of atolls with different boundary conditions to mimic distinct stages of the ongoing lagoon-filling process. The researchers also examined how reef sand apron hydrodynamics are related to changes of three variables: waves, tides, and geomorphology. By varying these parameters systematically, they could isolate and evaluate the impacts across a range of different settings.
As a geologist, we work in a parameter space that's largely unconstrained. That is, we simply do not know how large the waves were 10 million years ago at a given place or time, for example. With the Mike suite, we're able to quickly and efficiently test different scenarios, isolating and thus better understanding the most important hydrodynamic controls on geomorphic evolution of atolls.
Dr. Reinke's research revealed that as reef flats widen by shedding their debris towards the lagoon, energy decreases, and sediment transport becomes less effective. This effect will eventually stop the widening of the reef flats, and the lagoon will actually not infill. However, it will favor the initiation of islands, the subject of continuing research.